Mechatronics. Hey, welcome to Mechatronics. We're talking about stepper motors and a continuing edition. We've got this XYZ gantry stage here with these linear screws. They're actually ball screws, nicely configured with guides, rail guides, so they're well supported. Driven by stepper motors. We turned on one axis and we're driving using sort of a bang bang control or instantaneous acceleration at the end. We found this motion. We're running this at 2,000 steps in half stepping mode, or if you will, 400 steps per revolution. So we're getting approximately 5 revolutions of the motor. The pitch might be about a 1/4 inch, maybe approximately a 1/4 inch. So more than that. So maybe we're getting about 4 or 5 inches of travel, maybe as much as a pitch of 1 inch per rotation. Anyhow, we got that motion. What I'd like to do now is run multiple axes, or at least another axis. So we're going to save this sketch that we're just now creating. We'll call it part 2. And our goal is to now run move. We're going to drive multiple axes. And we're going to drive them in sequence. So one after the other, or in sequence, in series, I guess maybe you could say. So here we have the z-axis move. Let's next make a y-axis move. And oops, and to do that, I'm just going to, the code will look very similar. So I'm going to copy this code, move the y-axis. In moving the y-axis, we noted above that direction is attached to PB5, step is attached to PB4. So we now need to move the direction by setting the direction for the y-axis in PB5. And we needed to move the steps on PB4. First set it a little bit low, and then we're going to set it high. And we'll run at the same speed that we'll keep the same speed for z-axis and then the y-axis. Oh, yeah, there's the z-axis and here's the y-axis. So we'll run the, as you confuse myself there. So undo those couple changes. I changed them on the wrong one. Okay, down here, this is where the y-axis is. So we've got to set PB4 low. I even have to change that. I was so eager to make these changes, I did them incorrectly. So the direction is on PB5. The step is on PB4. So first I'll bring PB4 low. Then I'll bring PB4 high by putting a 1 in the PB4 location. I have the same speed and it should be now in good shape to go. So I'm connected. I will go ahead and download my code. So I'm getting my Z motion, my Y motion, Z motion, Y motion, Z motion. And if you noticed, we did a Z, a Y, then change the direction. So Y back, Z back. So there we have it. And we can even go one step farther and run our X-axis motion. To move the X-axis, we are on port H. On port H, we had pH6 for direction and pH5 for the step. So down here in the, we had pH6 for the direction, the X-axis, by the way, this was the Y-axis. And we had pH4, that's what we said. I'm gonna scroll up and look. pH6 and 5, excuse me, pH6. And then pH5 for the step. So that's 7, 6, 5. And 7, 6, 5. Okay. So now we'll run this, see if we get our X, Y, and Z motion, or Z, Y, and X. Okay, there's our Z. Bring it to the end. There's our Z. There's our Y. And there was our X. Couldn't quite see from the image what it was hitting. If I look over here, okay. Underneath this block this block here interferes with this block. That's what it was hitting. Perhaps if I kind of would have to go through a centering motion. But there you go. So now I got my multiple directions. I could speed this up if I wanted. Although we did find that we're probably pretty close to our max speed. I'll speed it up at least a little bit. See what happens here. Okay. So with this bang bang control, seems as if we're getting seems to be handling it somewhat acceptably. It would not surprise me if we're missing a few steps at least at the end. So this would really, in practice, not be acceptable behavior. But for our purposes, seems like it's working here. Okay. That I'm going to end this little video segment. Thanks for your time.